Okay, so here's another problem. Again, what I like to do is, interestingly enough, read what they want. I think that's a good suggestion for you too. Make sure you're answering the problem that I'm asking you to. So in this particular case, we're looking for forces in just 3 members. That's usually a tip-off that probably method of sections is going to be the best way. Not always, but possibly. So I'm just going to go ahead and mark those. So there's HG, HC, and BC. So that's conveniently right in this panel here. And now we have to decide whether we work the left side or the right side. I don't see a tremendous advantage. Either way you go, you're going to have to get some reactions. You guys have a preference, left or right? Left? Left sounds good to me. I'm sorry, what? Well, you do get an extra one here. You'd have an X component, but there are no X forces, so that's going to be a pretty easy one to get. And I guess if you're a minimalist, your free body diagram will be smaller on the left side than the right side. That's not always a good way to choose, but in this case, since there's not much difference, I'm going to go with the path of least resistance. So if I want to go left, then I'm going to look at the whole structure as a free body diagram and assume that I have a reaction at A in the X and Y directions. Those are my 2 reactions at the pin. And then I would have one over here at E2, but since I'm looking ahead and just going to end up using the left side, I'm not even going to concern myself with those. So if I do want to find just the reactions at A, then probably a good strategy would be to sum moments at E. When I do that, I eliminate EY and EAX, and I'll be able to write one equation for AY. So let's sum the moments using right-hand rule, and we'll sum them about point E. Make sure we're in equilibrium. So let's first account for all the applied forces. So I'll just take them closest to farthest away. So the closest one to E is this 3 kip. Or first I should say, all these applied forces, what kind of moment are they creating about E, positive or negative? Positive. So I'll start with the first one, that's 3 kilonewtons, and it's 1 bay away, and 1 bay is 3 meters. So I have 4 bays, 1, 2, 3, 4, each at 3 meters. So that's 3 kips times 3 meters. Plus, that's the positive moment for this second force, which is 9 kilonewtons. And its moment arm is 2 bays, or 6 meters. And all the way over to the third force, 6 kilonewtons. And that's 3 bays away, so that's 9 meters. So I've taken care of my 3 forces. Now I just need to take care of AY. I assumed it's acting up. So what kind of moment does that create about E? That creates negative moment. So there's my force AY, and the moment arm will be the total distance here. That's 12 meters. So we should be able to solve for AY. I think it's 10.5. No, it's not 10.5. It's less than 10.5. It's 9. I just guessed. Anybody else get 9.75? Is there anyone else there? Is it just Mr. Bellis out there? Mr. Penn, what did you get? 9.75? Excellent, excellent. Just to be complete, I'm going to go ahead and sum forces in the X direction. Make sure they're in equilibrium. And as you can see, the only X force we have is AX, so that's easy to solve for at 0. So I've got all my reactions on the left side. So let's draw that free body diagram for the left side. There we go. So I've got H. Got an applied force of 6 kilonewtons there at B. At A, I have my reaction force, which I just solved for, of 9.75 kilonewtons. Nothing in the X. And then I'll have my bar forces. So the first one will be the force in GH. This one will be the force in CH. And this one will be the force in BC. So let's talk about our strategy. First of all, you'll notice that we have 3 unknowns. We can write 3 equations, so that's great. Are there any points where these forces are concurrent? Any of the forces? I think the easiest one to see are these two. Even if you check the notation, they both have an H. So they do share H. So if I sum moments about H, I should be able to write one equation in BC. That's good. Is there another point that somebody might share? What did you say? Oh, C. Yeah, this one says C and this one says C. So let's, if we did a little projection out, we would see that those two pass through C. So I should be able to get GH. Is there another point where some forces might be concurrent? Well, this is a slightly different line. See that?
Yeah.
Now, if you really wanted to, you could project this line back. And I'll just show you that. There is a point out here in space where the horizontal line and this line connect. I'll just call it P. And of course, you could sum moments about P and get CH. You could do it that way. Which strategy would you like? So we are going to sum moments about H. We are going to sum moments about C. When I do that, the only unknown would be CH. It might be easier at that point just to hope that you got the first two right and just sum forces in the y direction and be done with it. Or you could figure out what this thing was, whatever you'd like to do. Let's wait on that. Let's plow through with what we know. So let's sum moments at H. We identified that one first. So again, using right-hand rule, I'm going to sum moments about H. So when I do that, the only force left is BC. What moment does BC create about H? Positive or negative? Positive. So I'll have the force BC times this distance. What is that distance right there? Well, it's given as 3 meters. So that force is creating a positive moment about H. This applied 6 kilonewtons passes through H. That's no moment. But I do have a reaction, and that's creating what kind of moment about H? Negative. So I'll have minus for the moment, and the force is 9.75 kilonewtons. And then whatever this distance is, which is one of the Bay distances, which happens to be also 3. So that's an easy equation to solve for. It looks like FBC is equal to 9.75. And it came out positive, which means it's in tension. Does it make sense that BC would be in tension? If we look at the original structure, all the forces are gravity forces. So I would imagine the whole bottom chord would be in tension and the whole top chord would be in compression. And we just found a bottom chord element and it did come out in tension. So that seems good. So next, let's go to the other point we identified. So again, I'm going to sum moments using right-hand rule for my sign convention about C and make sure that's in equilibrium. So I'm looking at point C. This is the force I need to deal with. So what I'm going to encourage you guys to do is to, again, look at the line of action of the force and follow it all the way up to point G, and then imagine that that force can be broken down into a horizontal and a vertical component. So this is force GF, can be anywhere on this line of action. I'll slide it up to G. That would give me a vertical force and a horizontal force. Which one of those creates moments about C? The horizontal force. So I just need to know what my geometry of this element is. That's this guy. This was a little bit tricky. So the run, this distance is the bay, which is 3. And what's the height? Yeah, it's 4.5 total, 3, so it's 1.5 to 3. That's 2 to 1. So 2 to 1. Now that doesn't make a nice, cute hypotenuse, but it's easy to calculate the hypotenuse. That'd be 2 squared plus 1 squared, that's 5, square root of that. So square root of 5. So I'm looking at this component, the horizontal component, that would be the 2 part. So it's going to be 2 over the square root of 5 times GH. Is that going to create positive or negative moment about C? Negative. So I'll have negative 2 over the square root of 5 times the force GH. And what's the moment arm there? That's this distance right here. 4.5. So I've accounted for the moment of my unknown force about C. What else do I have left over? The force at B and the force at A. Okay, the force at B, what kind of moment does it create about C? Positive. So I'll have positive moment. The force is 6 kilonewtons. The distance is one of these bay distances. That's 3. Then I have the reaction, which is up. What kind of moment does that create about C? Looks like it's clockwise. That will be negative moment. The force is 9.75 kilonewtons. And the distance from C to A is 2 bays, or 6 meters. So it looks like the force in GF is going to be negative. You guys have to figure that out for me. I can't do that in my head.
I have 10.05.
10.05? Anybody else get 10.05? 10.05? That's 10.0. That's basically 10. So I got 2 people saying 10. I like that. 2's enough. 2's better than 1, which is way better than none. So, good enough? Okay, so now we have to think about it. Do I want to go to all the trouble of trying to find point P? It won't be that hard, actually, but I could. Or do I just want to sum forces in the y direction? Yeah, I'll just sum forces in the y direction. A disadvantage of this approach is that I am going to bring in GH, which I just solved. So if I have messed up calculation for GH, I'm going to definitely miss this one too. If I went out here and found this point, which of course you could do that incorrectly also, but if you did write that correctly, you would have one equation and one unknown, and you wouldn't bring in any previous values. So summing forces in the y direction, what do I have? I've got, well, let's see, BC has no y component. CH, what's the slope of CH? So let's see, it's 3 to 3. Oh, it's 1 to 1. Look at that. That's easy enough. So the y component would be 1 to the hypotenuse, which is square root of 2, and it's actually acting down. So I'll have minus 1 over the square root of 2 ch. So that's my unknown here. And then I want the y component of gh, which is 1 to the square root of 5 force gh. That's acting up. What else do I have? The 6 kilonewtons is down. And my 9.75 reaction is up. And just to remind you, we have GH, so that can go right in there. So even though it's positive, because I assumed it's up, we found it was a negative value. So don't forget that when you plug it in, you plug in negative 10 kilonewtons. So from all that, we should find CH. Which I don't know what that's going to be. You'll have to just let the sign tell you. Well, this is a negative number, and that's negative. That's a positive. 5. I think it's going to be positive. You guys get a positive value for CH? Huh? You add those two together, you get 3.75. What's this? 1 over the square root of 5 is about 5. That's negative. It comes out to be a negative value? What do you get?
I get -1.
Negative 1? That seems reasonable. Anybody else get that? Mr. Lammy's going at it. Anybody else got a calculator?
Yeah, I got -1.
You got one too? Well, that's convenient. Okay. Yeah, I can't really tell you every time. I can't always predict the way the diagonals are going to turn out as well as I can, the bottom chord and the top chord under typical loadings. Okay, so this one took us just a little bit longer than the time frame. The timer now is like at 17 minutes. But again, we talked quite a bit about it and talked strategy. So I think, again, this is a doable problem for the exam. All right.